Hi, this is Ms. McCahan, and we're going to talk about perpendicular bisectors. So first, let's talk about what is a perpendicular bisector. Well, it's exactly how it sounds. It's a line or a segment that is perpendicular to another segment, and it cuts that segment in half. So you see that AP is exactly the same length as PB. So this CP is a perpendicular bisector. So here's what we know about perpendicular bisectors. First, if we have a perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. And all we mean by equidistant is that it's the same length. So from C to A, that's going to be the same distance as from C to B. All right, so as you can see down here, it says if CP is the bisector, then CA is equal to CB. Now the converse of that, remember converse means we just switch those around. So if we have a plane and I have this segment AB and the endpoints of the segment, first of all we have, this is perpendicular, okay, so CP is perpendicular to the segment AB. And it's a bisector, so you can see that AP is marked congruent to BP. So if we already know that D down here is congruent, DA is congruent to DB, then we know that D has to lie on the perpendicular bisector. So even though it doesn't show it, we know that D is going to be on this perpendicular bisector CP. So that's just the converse. So the original one is, if we know we have a perpendicular bisector, these that point on that perpendicular bisector is the same distance from those endpoints. Conversely, if a point is the same distance from those endpoints, then we know it lies on the perpendicular bisector. So let's look at an example of how we can use that. So in this first example, it tells us that AC is a perpendicular bisector of BD. So I'm going to mark that this is perpendicular with my little box. And I am going to mark this congruent and this congruent. Now, according to our original bisector theorem, since A is on this bisector, perpendicular bisector, then AB should be congruent to AD. So in order to solve for x, all I'm going to do is set 7x minus 6 equal to 4x. So if I solve that, I'm going to subtract the 7x over here with the 4x. That gives me negative 3x. And then I'm going to divide by that negative 3. So I get x equals 2. Now notice that they wanted us to find AD. So AD goes all the way from here to here. So that's a distance of 4x. So I need to fill that in. So AD is 4x. I'm going to plug in 2 in for x. So that gives me that AD is equal to 8. Now let's do one more. All right, in this, let's not look at all of that right now. Let's just look at this checkpoint. In this diagram, we have JK is a perpendicular bisector. So notice that they have the perpendicular sign marked. But let's go ahead and mark that. Since this is a perpendicular bisector, we know this is congruent and this is congruent. All right, and then we also know from that perpendicular bisector theorem, since J is on the perpendicular bisector, we know GJ and JH will be congruent. Also, do you notice that GF and HF are both 4.1? So if I'm going to list which segment lengths are equal, I'm just going to say what we just said. So GK and KH are congruent, GJ and HJ are congruent, are equal, and GF and HF are equal to each other. So they want us to find GH. GH is this whole length. All right, so we're going to set 2x equal to x plus 1. So let's do that and then solve for that. So I'm just going to subtract the x from both sides and I get x equals 1. Now remember, they don't just want what x equals, they want what GH is. So GK, if I plug in 1 in for 2x, I'm going to get 2. And then KH is also 2. So that means this entire length from here to here, all the way from here to here, is 4. Now, besides that perpendicular bisector theorem, we have what we call concurrency of perpendicular bisectors. So if I have a triangle and I make the perpendicular bisectors of that triangle, so remember, if I do side AC, F would be a perpendicular bisector. Okay, so you see how this looks like it's perpendicular to that side and it's right in the middle of that side. Same thing with EP is a perpendicular bisector, and DP. Those are all perpendicular bisectors of that triangle. Now what this says is, first of all, that all of those will meet. So that's what concurrency means, is that they're all going to meet at one single point. All right, now the other thing this says is that this distance in the middle here is going to be the same distance to each vertex. So P is the same distance from P to B, P to A, and P to C. So all of those yellow distances are going to be the same. So here's another way of saying that. So it says PD, PE, and PF are perpendicular bisectors. Those are the green lines. So if we know those green lines, then we also know that the yellow lines, PA is going to be equal to PB, is going to be equal to PC. So this is pretty handy if you ever want to know how to find the point where we're the same distance from 3 different points. You just need to find the concurrency of those perpendicular bisectors. So let's look at this diagram. In this diagram, we have the perpendicular bisectors meet at O. So again, I'm just going to highlight those so that we recognize that those are those dotted lines. So QO, RO, those are the perpendicular bisectors. Okay, now I'm also going to mark what's congruent. So if these are perpendicular bisectors, I know that's congruent to that. So MS is congruent to SP. PR is congruent to RN. And then QN is congruent to MQ. All right, now we also said from our concurrency theorem that O is going to be the same distance away from all of those vertices of the triangle. So MO, NO, and PO are all the same length. So I'm not going to mark those congruent, we'll just know that those yellow lines are all the same. So if I know that's the same, then let's go over here. We said MS is equal to SP, so then I know that that's also 22. Same thing over here. We said NR is the same length as PR. So let's label that 26. And MQ is the same length as NQ. So let's label that 20. Also, we said all the yellow lengths are the same length, and they labeled this yellow length 26.8. So I'm going to label that one 26.8, and I'm going to label this one 26.8. So from here on out, if they want me to find all of these lengths, it's going to be very easy. All I have to do is look at my diagram. So MO, that's from here to here, that's that yellow length, so that will be 26.8. PR, that'll be from here to here, so that'll be 26. MN is this whole distance, so we have to add 20 and 20, so MN will be 40. SP is this little length right here, that's 22. QN goes from here to here, that's just 20. And then MP, that's this whole length over here, the whole side, so that's 44. So we're going to be working a little bit more with perpendicular bisectors, and we're going to be looking at other points of concurrency later on.